exactly what's going to be affected.
It was actually on our Saturday, our second day up there, when I heard the words come up from the ground, "Oh, it looks like we won't have to bring you home tomorrow like we thought we might have." And it dawned on me how serious the situation must have been.
With the crisis averted, the shuttle's cabin explodes with gear. The crew finally captures Hubble.
Houston, we have Hubble on the arm.
Once we had it captured and I put the brakes on, then I think I started breathing again.
Copy, Scooter, outstanding work, and there's a big sigh of relief we heard from Goddard all the way here.
Hubble is locked down in the open shuttle cargo bay. The 4 spacewalkers are facing 5 very busy workdays outside Columbia, using the robot arm as a work platform. They proceed to give Hubble an overhaul.
A great start, and we're looking for...
It goes smoothly until spacewalk number 3. The astronauts are in the airlock, ready to go outside, when John Grunsfeld's water-cooled suit springs a leak.
The only clue we had was that there's a pressure sensor outside of the suit, and it was indicating a very erratic number. Finally, Jim took me off of the wall, put his hand behind the backpack, and felt that it was wet. Any water in the backpack is a bad thing, because if it freezes, it can crack things. Water expands as it freezes.
Just soaked.
More towels, please.
The crew can only be grateful that the accident occurred inside. They move on with the overhaul. Columbia's spacewalkers turn their attention to replacing Hubble's vision. The new camera, ACS for short, is 3 cameras in 1 and a major improvement. With a wide field channel, Hubble can now scan a bigger slice of sky and see deeper into galaxies and star clusters.
The wide field camera is really designed to do very deep fields of the sky, and it's going to be used to do things like looking at the formation and evolution of galaxies as a function of their age and the age of the universe.
To swap the cameras, an astronaut must actually float inside Hubble. One false move can damage the fragile telescope and the sensitive equipment inside.
It's $70 million worth of camera in my hands. So we were, again, slow, careful, methodical.
And then I opened up the door to the carrier that had the ACS in it, and we pulled the ACS out. Nancy swung around, and we guided it in to the telescope, latched it down, hooked it up, and that was it.
Hubble's vision is now keener, and its new heart is beating strong. One more day of arduous work to go.
Okay, Mike, I think I can do it without...
Day 10 of the mission. The repairs to Hubble are complete. On the last spacewalk, Grunsfeld lingers for one last moment with an old friend.
There's one point where I had to reach down and grab the shuttle, and that would be the last moment for me to touch Hubble. And so I just kind of paused there for a moment and looked at Hubble and held on with my hand just a little bit longer, kind of saying goodbye, almost as if I was, shaking Hubble's hand before coming back in. And so that was a special moment for me.
This would perhaps be the last time a human will lay hands on the Hubble Space Telescope.
Columbia, Houston, HST has established a good link with the ground through TDRS. It's time to sever the link with the orbiter and say a final goodbye.
Landing preparations begin hours before touchdown. Crew members close the doors over Columbia's cargo bay, strap themselves in wearing their orange pressure suits for landing. Next to launch, atmospheric re-entry is the riskiest phase of a space shuttle flight. The orbiter's skin heats up to 2,800 degrees Fahrenheit as a result of friction with the air. Special insulation on the outside keeps the astronaut safe and cool inside as the orbiter blazes a fiery trail across the sky.
It's just like a flash of a flash bulb. It's amazing to look out, and then you see these reds and yellows and greens kind of over the vehicle, really bright up at the nose, so you kind of come up in your seat to look out and see a little further, and it's brighter, and you look a little further and it's brighter, and you're like, oh, I don't want to look any further, it's too bright, too scary up there.
See the nose getting brighter now, bigger? Yeah, I don't want to look, Scooter. I know, that's what I felt.
With the mission complete, Hubble would begin producing its sharpest images and most important discoveries to date. To astronomers, Hubble had become a whole new telescope. They used it to search for the first galaxies, to track exploding stars to measure the expansion of the universe, to probe stellar dust rings for planets being born. These discoveries sharpened the debate about Hubble's future.
All of these questions are opened up because we have new capability, and that's really why people are looking at keeping Hubble going. It's not because it's just an old telescope that people love, it's because it's a new telescope every time we go up and service it.
For as long as there have been people, we have been looking at the sky and asking questions about what is it that we see there? What's going on? What connection does it have to us? And suddenly you find yourself using a tool like Hubble, looking at the heavens and seeing our own birth there. It's extraordinary.
In the turbulent back roads of our galaxy, astronomer Jeff Hester believes he is witnessing the birth of our own solar system. This revelation began with a more down-to-earth discovery that ordinary meteorites, chunks of asteroids that had fallen from the sky, contained traces of a rare radioactive element. Steve Desch and colleagues at Arizona State University placed these space rocks in a high-tech analysis chamber and bombarded them with a beam of electrons. The sensors detected byproducts of a kind of radioactive iron that is produced only by a rare breed of immense stars. To Hester, this clue pointed to regions like the Trifid Nebula, a hotbed of star formation some 2,000 light-years away. Here, intense radiation from massive stars has sculpted vast clouds of dust. This Hubble image shows a cosmic cocoon, a column of dust in which a cluster of small stars is being born.
What you're looking at here is an interstellar cloud that's being illuminated by that intense radiation. And when that intense radiation falls on the surface of that cloud, it's a little bit like turning a blowtorch on a block of dry ice. If you think about what's going to happen, the radiation from those nearby stars is eating away at this clump of material. And so if you waited for a few tens of thousands, say 100,000 years, and looked at this again, then what you'd expect to see is that that would have been eaten away, and this newborn star would just be emerging from behind this front.
By that time, radiation from the large stars may well become a blast wave. This is where the radioactive iron comes in.
We know that meteorites like these contain evidence that the solar system once held certain radioactive elements. Iron-60 is one of them that was discovered recently. There's about a dozen others. And it's been a question for a long time where these radioactive elements came from. There were lots of theories about it. But the discovery of the Iron-60 really forced everybody to think about a supernova being near the sun as it formed.
Iron-60 is made in massive stars. It's then blasted out into its surroundings when those stars go supernova. That's really the only source that you have for Iron-60. And so when you find Iron-60, evidence for life